I'm just gonna go over drawing 3D-6, which is machined housing fixture guide. So that's what the model is going to end up looking like, and our dimensions are here. So this is all the information that you're going to need to build this object. So I'm going to jump into Inventor here. I'm going to start a new drawing in metric. And I'm going to start, I find it generally easiest to start with the circles and attaching those circles to the base point. So I picked a plane. I'm going to grab a circle here. Center point is going to go to that origin point, which is going to anchor that circle. I'm going to start with the smallest of the circles, which is a diameter of 12. Now that smaller circle within it is just the chamfer that you're seeing. So that that smaller circle is just this chamfered bit that you're seeing in orthographic projection. Likewise, this outer circle here, the two circles that are really close together, you're just seeing the chamfer off bit. So just keep that in mind as you're creating this. So I'm going to create a larger circle now, which is going to be the outside perimeter of this part, which is a diameter of 50. And also the circle for the lower section, this section here, which has a diameter of 25. All anchored to the origin point. Okay. So at this point, I am already done my sketch. And now it's just a matter of making some extrusions. So I'm going to extrude out this top circle here. So I'll click on that. That's going to come up 3 millimeters. Again, it gets rid of my sketch. I just got to bring that back in. So I'll click on the extrusion, right click on my sketch, and turn on the visibility. I'm going to go to extrude again. And this time I'm going to do my this bit here, which is going to be extruded down from this plane here, which I've started my sketch on. It's going to go down 40 minus the 3, so 37. So this time I want to flip the direction in my window here. So I can click this icon here to flip it and change my millimeters from 3 to 37. Press OK. And now I'm going to extrude this larger diameter circle, and that's going to come the same way, but it's going to go down 12. So I'll change that to 12 and press OK, and there we have like a good basis of our part. Now I'm going to add the details to it. So I have chamfer. A chamfer is just like a angle cut to take away any sharp points of a particular part. This is going to be a metal part, so if you can imagine like 90-degree metal there, that's going to get very, very sharp and dangerous. So they often shave off the edges, which we call a chamfer. So I got a tool for that right here. If we take a look at the diagram here, it mentions that the chamfer is going to be 1 by 45 degrees. So it's going to come up 1 millimeter, or come down 1 millimeter from the corner, and then shaved off at 45-degree angle. So let me go back into Inventor, and both of those chamfers are going to be like that. So I got one up here. So for the chamfer, I'm going to go into my distance and angle. change the distance to 1 and leave the angle at 45. And then it's going to prompt me to click the face, so I'm going to click that top circle there, and then my edge, corresponding edge. Now I can press apply here, and then I can stay within the same command and put my chamfer on this edge as well. So I'm going to click on the face and then the edge and press OK as I'm done on my chamfer. Alright, so there I go. At this point you can see like it might be advantageous to turn off my sketch, turn off the visibility, as this is kind of getting in the way anyway. So the last detail I'm going to add to this is the holes. So for that, generally with a hole, you're going to start with a point. And so I'm going to start a new sketch. You do that within a sketch. So I'm going to go to 2D sketch. I'm going to click on this surface here, as that's where I want my holes to be. And you'll see it focuses in orthographically. And I'm going to click on my point here. Before I do that though, I'm going to create a circle that's going to outline where my holes are going to go. So I'm going to create basically that circle here, and I'm going to make it a construction line, so I'll show you how to do that as well. So I'm going to go into my circle, I'm going to grab the origin point, and the circle has a diameter of 40. Now if I right click on the circle, I'm going to change it to construction lines, that option right there, and you'll see it's become serrated. That's not going to be picked up by like any extrusions or count as any sort of bounded area, so it can be advantageous to do it that way, and becomes a little less cluttered, and you know that it's just being used for laying out purposes. At this point I'm going to go to point, and I know that I have one right on my y-axis, and where that 40 diameter 40 circle is gonna intersect. So there I have my point. It's a little tough to see, but it's right where that green node or yellow node is there. The next one I'm gonna just kind of throw down along the circle, and then I'm going to lock it in place with the dimension off my origin point. So if I take a look at my drawing, I know that it comes up 12 from my x-axis. So I'm going to go to my dimension tool from my point and from my x-axis. Currently it's at 9, and I'm going to change that to 12. So it raises it up and it remains on that construction circle there. I'm going to do the same thing to the other side. This time I can polar track it till it intersects with that construction circle I have in there, and there I got my other one too. So those points are going to represent the 3 circles that, or 3 holes that I'm going to put in. So I'm done my sketch here. Now going back to the drawing here, I just want to go over what this means. So here I got these three circles, and it says M3 times 0.56H. So, and also by the sectional view, I know that these holes are going to go all the way through my component. So they're through holes. Now, the M3 means that it's got a metric diameter of 3 millimeters. The 0.5, we can ignore it for our purposes, but it means it's going to have a distance between threads of 0.5 millimeters. So it's going to be fine threaded, but again, we can ignore that. And the 6H, again, it's more for mechanical purposes, technical purposes, but the 6H is your tolerance, the thread fit of the particular screw that's going to be used in it. And then the 3PLCS, I think means 3 places. I think it's safe to assume. So we got 3 of them there. I think that's what it's referring to. So going back to our drawing, let's add those holes in. So we're going to go to the hole tool. Automatically, it's going to pick those center points that I have positioned. So I don't, that's already taken care of. I've got my through hole, my simple hole selected. This time it's not going to have a counter bore or a spot phase or a countersink. It's just going to be a straight through hole. This here means termination is going to go through all, which is great. And it's going to have a diameter of 3 millimeters, which matches the M3 from the drawing. So at that point I can press OK. And now I have my part. And so that is 3D-6.